Okay, let's get this. Suppose we have a polynomial like this. Then the following two instructions require the same thing. The same calculations are required. Divide p of x by x minus 5 or find p of 5. So suppose if we're told to divide p of x by x minus 5. Okay. Then what I'm going to have to do is set up synthetic division. So this is what the instructions are. Then I'm going to look at that and take the opposite sign. So 5 will go in the box. And here I got to make sure every power of x is represented. So I get it started. 1 times 5 is 5, and then I add. 4 times 5 is 20, and then we add. 2 times 5 is 10, and then we add. Negative 4 times 5 is negative 20, and then we add. And negative 3 times 5 is negative 15. I am now done. That is my remainder. And this is the quotient. And so I've got constant x, x squared, x cubed, and x to the 4th. So p of x is going to be equal to the divisor, what I divided by, x minus 5, or x minus the number in the box. Both are the divisors, times the quotient, plus the remainder. But plus 0 is nothing, so it's left off. Now, since the remainder is 0, then x minus 5 is a factor of p of x. And we can see it is. P of x is equal to x minus 5 times something else. And there's no remainder to add on. Now, if we had been told, if we'd started with this and the instructions had said find p evaluated at 5, then we would have to set up synthetic division. And you set up synthetic division and you put the number as it is inside here. And then when I get to the remainder, that is equal to, the remainder theorem tells me that's equal to p of 5. And so p of 5 is equal to 0. Okay. All right. So, also, p of 5 is equal to 0, so we say 5 is a 0 of p, because p evaluated at 5 is equal to 0. Okay, now, what if we have the same thing, same polynomial that we're starting with, but now the instructions tell us to do something else. I'm just trying to find some clean paper here. There. Let's divide p of x by x plus 5. And let's use this to write p of x, the fraction p of x over x plus 5. Okay. Now this is different from the last one. So if I'm going to divide P of x by x plus 5, if that's the question, then what I do is I set it up with synthetic division, but I take the opposite sign, and that's what goes in the box. And then I put these the same, making sure every power of x is represented. Okay, 1 times negative 5 is negative 5, and then I add negative 6 times negative 5 is positive 30, and then I add I think 12 and 18 is 30. So 30, negative 18 plus 30 should give me 12. Then 12 times the number in the box, so 12 times negative 5 is going to be negative 60. And I add negative 74 times negative 5 is going to give me a positive number. So now I'm going to bring this in. Negative 74 times negative 5 is going to give me 370. Then I add, and 387 times negative 5, whoops, 387 times negative 5 is, and then if I add 15 to that, so I am done. That is my remainder. And this will be my quotient. So constant x, x squared, x cubed, and x to the 4th. So P of x is equal to the divisor. So I divided by x plus 5, or you can say the divisor is x minus the number in the box, which is x plus 5, times the quotient. Plus the remainder, so plus negative 1920. Now, if I'm told to find that fraction, then I have to divide every term by x plus 5. Now here the x plus 5's cancel. And so I'm left with that. Okay, now the remainder was non-zero. So x plus 5 is not a factor of P of x. When I write P of x divided by x plus 5, I get a remainder. Okay, that's like dividing a number. So 9 is a factor of 18 because if I divide 18 by 9, I get a whole number. 7 is not a factor of 18 because if I divide 18 by 7, 18 divided by, I do not get a whole number. Okay, so we have a similar type of thing going on with polynomials. P of x divided by x plus 5, I don't get an integer polynomial there. I get a fraction stuck on, so it's not a factor. Now, what if the question had been to, given this, find P evaluated at negative 5? Well, if that is the question, then what we do is the number inside the parentheses is exactly the number that goes in the box. And P evaluated at negative 5 is going to be the remainder. So P evaluated at negative 5 is negative 1920. I could have done it directly. But this is very prone to error because you have to plug in -5 in the parentheses, and you have to make sure you're carrying out order of operations. If I'm going to do that, then I'm going to have to put it in my calculator exactly as I've written it, exactly, and I can't be making any mistakes whatsoever. So I'm going to clear that. So parentheses -5 to the 5th. Get that ladybug out of the way. Then minus, in parentheses, -5 to the 5th. It's really hard to do this when you're a mouse. -5 all to the 4th. Then minus 18 times -5 cubed. Then minus 14 times -5 squared, which is positive 25. Plus 17 times -5. Plus 17. Okay, my mouse is just not obeying. Okay, and then plus 15. Let me double check that before I press enter, because if my mouse has let me down anywhere, minus 18 times -5 cubed. Okay, enter. All right, and so we got the same answer. And I think in this case, doing it with synthetic division is going to be the better way to get there. Okay, so that ends